Okay, this is our intro to geometry, right triangle application notes. So 1.5. It says use sine, cosine, or tangent to solve each problem involving right angles. So first we're going to talk about two different angles here. The first one is angle of elevation, and then the second one is angle of depression. So the reason why they have these names is we're looking where the observer is, okay? And where the observer is always going to be attached to the horizontal line, okay? This could be an imaginary line, this could be the ground, whatever it's going to be. If the angle is an angle of elevation, it's going to be above that horizontal line, which means that the observer is looking up, so the angle is going up, hence angle of elevation. For angle of depression, the observer could be looking down or away from that horizontal line, which means the angle would be going down, so it'd be an angle of depression. So let's look at examples of each. So on the first example for angle of elevation, it says from a distance of 300 yards, a spectator watches a rocket ship take off. When the rocket reaches an elevation angle of 70 degrees, it can be no longer seen by the naked eye. What is the height of the rocket at this point? Draw a diagram, then solve. Okay, so we have our little person here. Okay, he's our observer, which means he is observing from the ground. Okay, he is watching a rocket be launched. Okay, so this is his sight. He's watching a rocket being launched. Okay, and it says that the elevation angle of this is 70 degrees. So that means this is 70 degrees and he is 300 yards away from that rocket. Okay, so it wants us to find the height that the rocket can no longer be seen. So that would be this value here, which is x. Okay, so notice that we have our angle, okay, 70 degrees. We have our distance of one side being 300, and we need to find the distance x. Well, since we have a 70-degree angle and the adjacent value, and we need to find the opposite value, we know that tangent of theta is equal to opposite over adjacent, which means tangent of 70 is equal to x over 300. Well, we would type this into our calculator and we get x is equal to 824.24 feet. So once the rocket is 824 feet above ground level, then the observer, the spectator, can no longer see the rocket with the naked eye. Okay, now let's look at another example. And this says, as Wanda flies her kite, she uses all 42 feet of string on the roll. The string makes a 50-degree angle with the horizon. Neglecting Wanda's height, determine the kite's distance above the ground, draw a diagram, and solve. Okay, so here's our person, our observer. She's flying a kite, and we know that the length of her string is 42 feet, okay? And we know that she's level with the ground. And they tell us this is 50 degrees. And it wants us to find the height. It says determine the height of the kite from the ground. So we need to find this one here, and this is our x. So notice we're given now our hypotenuse, and we have to find our opposite angle. Well, opposite and hypotenuse is sine, so sine of theta is equal to opposite over hypotenuse. So that's sine of 50 is equal to x over 42. Okay, use some algebra, plug it into your calculator. We get x is equal to 32.17 feet. So that means the kite that Wanda was flying is about 32 feet above the ground. Next example, it says a billiard ball lies on a pool table 1 mark to the right and 2 marks below the left corner pocket. The ball is to be hit into the pocket. If the marks on the rail are evenly spaced, what angle would the path of the ball need to make with the left rail? So first we draw out our diagram. So this is a billiard table, okay? And then it's saying that on this billiard table there are marks on either side. Well, it says it lies 1 mark to the right, okay, and 2 marks below the left corner. Well, this is the left corner right here, okay, and this is the right corner, so 2 marks would be right here. And it says what angle would be the best path for the ball to make the, what angle would be the path of the ball need to make with the left rail. So it wants us to only use this side here, okay? Which means we would have to find the angle right here, this angle theta, in order to find what would be the perfect angle to go into that left top pocket. Okay, so we have this distance as 1 because we're 1 mark and this distance as 2, which means from the angle we have adjacent and opposite, and we know adjacent and opposite is tangent. So we would say tangent of the angle is equal to opposite over adjacent, because that's SOHCAHTOA. And so that's tangent of the angle is equal to opposite, which is 2, divided by adjacent, which is 1. And in order to find that angle, we would have to do the inverse of tangent. So the angle is equal to the inverse of tangent of 2, because 2 over 1. And we would get that the angle theta is equal to 63.44 degrees. Okay. Next example, it says a 12-meter flagpole casts a 9-meter shadow. Find the angle of elevation of the sun. Okay, so a 12-meter pole, okay, cast a shadow, a 9-meter shadow. Okay, so we're trying to find this here. Okay, find the angle of elevation of the sun. So angle of elevation, remember that's above the horizontal line, so that's this angle here. So we have adjacent and opposite, so we know that's tangent. So tangent of theta is equal to opposite over adjacent, so 12 over 9, which means that theta is equal to the inverse of tangent of 12 over 9, which is equal to 53.13 degrees. Next example says you are 200 yards from the river. Okay, so here's the river and you're 200 yards from it. Okay, there's my river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So you walk 400 yards instead of that 200 yards. You want your exercise. Find the acute angle between the path at the river's edge. So it wants us to find this angle. And when it says acute angle, that means it is a small angle, an angle smaller than 90 degrees. Okay. So if we want to find that angle and we're given adjacent and hypotenuse, then we know we're using cosine, because cosine of theta is equal to adjacent over hypotenuse. So cosine of theta is equal to 200 over 400. In order to find theta, we have to do the inverse of cosine, which is the inverse of cosine 200 over 400. And that gives us theta is equal to 60 degrees. Okay, last example here. It says a 12-foot ladder leans against a wall so that the bottom of the ladder is 4 feet from the base of the drawing. Okay, so A says draw a picture to show the ladder in the wall and then later label the dimensions. Okay, so we have a 12-foot ladder leans against a wall. So here is my wall. Okay, here is my ladder. We know it is 12 feet. It's leaning against a wall, and we know the bottom here is the distance from the ladder to the wall, which is 4 feet. Okay, and it wants us to find, okay, so it doesn't say exactly where our angle is just yet, but I know that we don't have x, which is the height of the wall. So it says find the height that the ladder extends up the wall. So it wants us to find x. Well, notice we're given the hypotenuse and we're given a leg, so we could just use the Pythagorean theorem to find the other leg. So that's a squared plus b squared equals c squared. So 4 squared plus b squared is equal to 12 squared. So 16 plus b squared is equal to 144. So that means b squared is equal to 128. So b is equal to 8 square roots of 2, because we take the square root and we do the prime factor tree. Okay, so that is our x. So this is 8 square roots of 2 feet. Okay. It says, what is the measure of the angle formed between the ladder and the wall? So between the ladder and the wall would be this angle up here. And it wants to find that measure. So using that angle, we have the opposite, which is given to us, 4 feet, and we have the hypotenuse, which is given to us, which is 12 feet. Well, opposite and hypotenuse is sine, so sine of theta is equal to opposite over hypotenuse. So sine of theta is equal to 4 divided by 12. In order to find that angle for theta, we take the inverse of sine, so theta is equal to the inverse of sine of 4/12, which is equal to 19.47 degrees. Okay, and these are my answers.